For this problem, we have the integral of 24 divided by secant 2x minus 1. Okay, so we're going to evaluate this integral. It's going to take a little bit of work. So the first thing that we're going to do is multiply by the conjugate of the denominator. The conjugate meaning there's two terms, so we're going to multiply by the same thing, secant 2x minus 1, except we're going to change the minus to a plus. The reason we're going to do that is because it creates a difference of squares and some things are going to cancel out, and perhaps maybe the next integral we get will be something that we're able to solve more easily. So multiply it by the top, because you have to multiply, when you do this, you have to multiply it by the top and the bottom, because you're actually multiplying by 1. So we'll multiply the top by secant 2x plus 1. And on the bottom, we get secant 2x minus 1, which was already there, times secant 2x plus 1 dx. Okay, so like I said, the middle two terms is a difference of squares now. The middle two terms are going to cancel out, and you basically get the first two terms squared and then the second two terms squared. Okay, so our next one, we're going to go ahead and multiply through the 24, so we get 24 secant of 2x plus 24. And then on bottom, we're going to get secant squared of 2x minus 1 dx. Okay, so you may recognize that in the denominator we have a trig identity. Secant squared theta minus 1 is the same thing as tangent squared theta. So let's go ahead and change that out. This is going to change into tangent squared 2x. So we have 24 secant 2x plus 24 over tangent squared 2x dx. Okay, now let's split up these two. So since we have, before when we started, we had two terms in the denominator and one term in the numerator. Now we have the opposite. We have one term in the denominator and two terms in the numerator, which means we can split this up now into two fractions. We couldn't do that before. So this is equal to 24 secant 2x over tangent squared 2x dx plus second integral is 24 over tangent squared 2x dx. Okay, now let's see if we can simplify these a little bit. What I want to do on this fraction here is I want to change them into sines and cosines, both the secant and the tangent squared, and see if anything will reduce. So this becomes, let's put the 24 out front. And this becomes a 1 over cosine of 2x. And then the denominator, keep in mind this is squared, so this will become sine squared of 2x over cosine squared of 2x. Okay, and the second integral, for now, we're going to leave as is. Okay, now when you have a fraction divided by a fraction, it's called a complex fraction, you can flip and multiply the bottom fraction. And if you do that, you'll notice when we flip this one up, one of the cosines is going to see these two terms are the same except this is squared. So when we flip this up and multiply, the sine squared nothing happens to, but one of the cosine squareds is going to reduce with this cosine. Okay, 24 is going to remain out front. Okay, so we get cosine 2x, not cosine squared because one of them's reduced. Move this up. Divided by sine squared of 2x dx plus 24 over tangent squared 2x dx. Okay, so these are the two integrals that we're going to solve. and we're going to solve them separately. Okay, so I'll call this one the first integral and this one the second integral. Okay, so I'm going to go ahead and start on a new sheet of paper. I'll rewrite the first integral. Okay, so this is the first integral, which was 24, 24 is out front, of cosine 2x divided by sine squared of 2x. Okay, so for this particular integral, we're going to use U-substitution. Forget my dx. U-substitution. So we're going to set u is equal to sine of 2x, which means we need a du, which is 2 cosine of 2x. That's chain rule, dx. And let's solve that for dx. So dx is equal to du over 2 cosine of 2x. Okay, so let's go ahead and rewrite this. This is equal to 24 of cosine 2x over, now we used our u here, so instead of sine squared of 2x, I'm going to write u squared, because if I squared this, this would become sine squared x. So this is u squared. And then instead of dx, I'm going to write this, so du divided by 2 cosine of 2x, which is nice. We know this works now because we're able to get rid of all the x variables in this problem. So this cancels with this. We have a 24 out front and a 2 down here in the bottom of this fraction, so that'll become a 12. So this integral will become 12 times the integral of 1 over u squared du. Okay. So this is a fairly simple integral to take. You can make the exponent negative and move it up to the front. So this is 12 times the integral of u to the negative 2 du. You remember, add 1 to the exponent and divide by that new number. So this becomes 12 u to the negative 1 divided by negative 1 plus c. Okay, let's move that. This is a negative exponent, so let's move it back to the bottom. Let's multiply 12 times, well, divide 12 times negative 1, we get negative 12. So negative 12 over u, because the exponent was negative, that's the reason we wrote it as a negative, but once you put it back to the denominator, you don't need to write a 1 denominator here, plus c. Now let's substitute in our u. Our u is here. So this becomes negative 12 over sine 2x plus c. And as one last step, let's go ahead and change that into a cosecant. Let's not leave it as a fraction if we can help it. So negative 12 times cosecant, excuse me, of 2x plus c. Let me rewrite that one more time. Cosecant of 2x plus c. Okay, that is integral number 1. Okay. So let's go back over to where we had that written down. And under integral number 1, I'm going to put this is equal to negative 12 cosecant of 2x. I'm not going to put the plus c here because this one's going to be written, and then we'll put the plus c after we put these both together. Okay, let's go for integral number 2. Okay, so I'll rewrite that here. Integral number 2 was the integral of, let's put the 24 out front, of 1 over tangent squared of 2x dx. Okay, for this problem, I'm going to reduce this to sines and cosines. So we get 24 times the integral of, if you change tangent to sines and cosines, it's sine over cosine. But since it's on bottom, it's technically a cotangent. Okay, so we could have wrote this as cotangent. In fact, let me go ahead and just do that. Cotangent squared of 2x dx. That way I won't have to talk about too many steps. So now that we've changed it to cotangent, we can change that to cosine squared of 2x divided by sine squared of 2x. So this is equal to 24 times the integral of cosine squared 2x over sine squared 2x dx. Okay. What we're going to do is we're going to change this numerator. We're going to use the trig identity, sine squared plus cosine squared equals 1, to substitute this in. So this will be equal to 24 times 1 minus sine squared. That's the trig identity. We'll need to keep the 2x on the inside. Divided by sine squared of 2x dx. Okay, just like on the other integral, now that we have two terms in the numerator but only one term in the denominator, we can split this up into two fractions like we did before. So this will become 24 times 1 over sine squared of 2x. And then notice this is the second one, so it's going to be minus sine squared of 2x over sine squared of 2x, which of course is a 1. So it'll be minus 1. Okay, so now I'll write it as two separate integrals. So it'll be 24 times the integral of, let's write this as a cosecant squared. So cosecant squared of 2x dx. And then this one will be, remember the 24 goes to both because the 24 was out front of all of it. So I can't just write the 24 in front of the first integral and not the second integral. So this one needs a 24 as well, times the integral of 1 dx. Or you can write the 1 if you want. I'm just going to write dx. It's implied that there's a 1 there. Okay. Now the integral of this, well, this is an integral formula that you may have written down somewhere. You may have a table of integrals, but I'll write this. Let me choose a different color so I can write that this is part of a formula. We have the integral of cosecant squared of ax, a being 2 for our particular problem, dx, is equal to negative 1 over a cotangent of ax plus c. Okay. So that helps us take the first integral. And of course, the second integral is just a constant, so it just becomes an x, or 24x. Okay, so let's look at that first one. So our a is 2. So we have 24 out front. Don't forget that. So here's the 24 out front. 1 over a. So negative 1 over 2 cotangent of ax. So the a is 2, so 2x. Okay, that takes care of that first integral. Let's do the second integral. Close. And then 24 again, and then the integral of dx is x. And then we can put our plus c. Okay, let's clean that up before we go back to the other page. So 24 times this will give us negative 12 cotangent of 2x, and then plus 24x plus c. Okay, that takes care of that second integral. Now let's go back to where we stopped and we split up, back to the original integral. Okay, and let's write that down. So that'll be minus 12 cotangent of 2x plus 24x plus c. And that's it.